Hi guys, welcome to my channel, The Analyst. Today we'll speak about random forest. Random forest can be used for both classification and regression purposes. That totally depends on your target in your dataset. Okay, it's what you're trying to predict. For the purpose of this video, we'll make use of the German credit dataset. Over here, the target attribute basically is whether someone is a good credit risk or a bad credit risk. I'll attach the data set in the description for you to go through. So let's move into the demo. The first step is basically I clean up the environment. I set the seed so that I can replicate my outputs. And here I'll be using the random forest library. To read more about the library, you can just type random forest over here in the help section and read through the entire documentation. I always suggest that you go through the documentation for your knowledge and better understanding. The next step what I do is that I read the German credit dataset and I basically use the head function to view the data. Now here is my German credit dataset. Okay, you can just click on credit data and open it up. Like you see, I have 100 observations and I have 21 variables. 21 variable from this is the target, which is over here. You have only two values in the target, number 1 and 2. 1 indicating good credit risk, 2 indicating a bad credit risk. Now let's see the data type. It's an integer data type. Now there's a problem with the integer data type, so we need to convert it into, the problem being that when you use random forest, if your data type is anything other than a factor, then it assumes that you want to perform regression. But since we want to perform classification, we'll convert V21 as a factor. So I use this as a factor on the 21st variable and I use the structure function to see the data. So as you can see over here, V21 is now a factor. So my target is a factor. So now when I feed the data to the function, it will assume that it is supposed to apply classification and not regression. Alright, moving on. So if we read through the documentation, you would make out that here, if you look at the y variable over here, which is your target, a response vector, if it is a factor, then classification is assumed, otherwise regression is assumed. So we've converted it into a factor. Now when we feed it to the function, automatically classification will be assumed. Then the next step what we do is that we will split the data into training and testing data. So 90% is my training data and 10% is my test. Okay, so I have to train and a test object over here. Now I feed that data, the training data, to the random forest function and I want to predict V21. I'm using all the data. There are two important attributes of random forest. One is mtry and the other is ntree. I hope you'll understand how random forest works. So in random forest, what happens is that from your original data set, you will make multiple other data sets over where replacement of data is allowed. On each of these data sets, a tree will be constructed. Okay. Now, why is it called random? It's because when you're forming these data sets, by random, we sample out data from the original data set and put it into the new data set that we're trying to form. Also, in each of these data sets are unique because we set the replacement as true. So in one single data set, you could have a sample picked up from the original data set multiple times. Another reason why we call it as random forest is because of the number of variables that we use to form the model. Like here we have 21 variables and one target variable. From the 20 variables, excluding the target variable, by default, if it is a classification problem, then the function will take mtry as the square root of p. So since we have 20 variables, that would be around 4. And if it was a regression, then it would basically take the number of variables divided by tree. Now that is the optimized values that they think works. That is why they've taken it by default. However, it is good to play around with the values and basically apply a loop to check for what value of mtry and for what value of ntree you're getting the best output. Anyway, we'll look at that moving further. Okay. Yeah, let's use the random forest function. I'm feeding in the train dataset, and here, okay, I use random forest train. As you can see, like I explained earlier, by default the number of trees, which is basically ntree, is taken as 500, and the number of variables at each split is taken as 4, which is the square root of 20. So mtry is taken as 4. The out of bag estimate of error is 23.35%. The lower the OOB, the better the classification. Now, like I said earlier, to find the lowest OOB, we need to vary the mtry, which is the number of variables at which the split happens, and the ntree, which are the number of trees that are randomly formed. Apply a loop on both of these variables and check. You have to tune your random forest model to perform the best. This is not within the scope of the video, but you can just write a simple loop in order to get to the results and tune your model. Then we also have the confusion matrix over here. Okay, it's not classifying it that well. Let's now basically check on the test data set how well our model performs. So I have my random forest train and I feed in the test data set. I save it to PR, and then I plot a confusion matrix. Okay. From here also you can see that pretty much a lot of misclassifications. Let's check for the accuracy, which basically is the sum of the diagonals divided by the total number of records over here. You can see you get a 72%, 72.8% accuracy. Not that great, but it can be improved. Like I said, try and vary the mtry and the ntree attributes and check and try and improve upon the OOB estimate of error rate. Reduce it as much as possible. Now you don't need to do this manually by just plugging in values, just apply a loop and check. Alright guys, that's it for this video. If you like my video, please like and subscribe. Thank you.